Already at this point in the semester, we've gotten to the point where we can estimate the value of an entire company. And so in this example, we're given a financial projection for a number of accounting variables for this company, and we're asked to come up with an estimate of its share price. So the first thing we're going to want to do is we're going to want to convert these accounting variable projections into cash flows. And so this problem tells us to assume that it's currently the start of year one, and all cash flows are going to occur at the end of the year. So let's start by coming up with an estimate for the cash flows in year one. And so the first thing we want to do is calculate the EBITDA in year one. And so we get that by subtracting our operating expenses, in this case, it's our cost of goods sold, from our operating revenues, the sales. And so our EBITDA in year one, in this case, is going to be projected to be $108 million minus $75.6 million, which is equal to $32.4 million. And now, using this operating income, our estimate for EBITDA in year one, we can also estimate the taxes in year one. And so we're going to want to subtract from this EBITDA, which again is $32.4 million. We're going to want to subtract our depreciation tax shield, which lowers our taxable income, and then multiply by our tax rate, which is 35%. So our taxes are going to be 0.35 times our EBITDA, which is 32.4, minus our depreciation tax shield, which is $10 million. And if we multiply this all out, we get a value of $7.8 million. So our taxes in year one are $7.8 million. And then finally, the change in working capital is found by subtracting 17.3 from 16. 17.3 minus 16 is equal to 1.3. So our change in working capital here is going to be $1.3 million. Now we have all the information we need to estimate our cash flow in year one. And so we're going to use our cash flow equation. And so the cash flow in year one is going to be our EBITDA, $32.4 million, minus our taxes, 7.8, minus our capital expenditures, 15.1, minus the change in working capital, 1.3. And when we do that, we get a value of $8.2 million. So our cash flow is $8.2 million. That's what we're forecasting for our cash flow in year one. And so we can go through the same process for each of the first 7 years. And when we do that, we get 8.2, 8.8, 9.5, 13.6, 15.0, 16.8, and 19.7. So once we have our cash flows for years 1 through 7, now we can discount them at the cost of capital, which is 15% per year, to calculate the present value of our cash flows. So when we do this, we find that the present value of these cash flows are equal to $7.1 million, 6.7, 6.2, 7.8, 7.5, 7.2, and $7.4 million. So now we have the present value of all our cash flows from years 1 through year 7. The next step is to estimate the present value of all cash flows after year 7. And so in this problem, we're told to assume that cash flows after year 7 are going to grow in perpetuity at a rate of 3% per year. And so our cash flow in year 8 is going to be 19.7 times 1.03. So it's going to be equal to 19.7 7 times 1.03, which is equal to $20.3 million. So that's going to be our cash flow in year 8. And so we can actually draw our cash flows for years 8 onwards on a timeline. So we get $20.3 million in year 8, 20.3 times 1.03 in year 9, 20.3 times 1.03 squared in year 10, and this is going to go on in perpetuity. And so note that this sequence of cash flows is a growing perpetuity. And so we can use our growing perpetuity formula to calculate their present value. And so remember that the formula for a growing perpetuity is x over r minus g, where in this case, x is going to be 20.3, r is our cost of capital, 15% per year, so 0.15, and our growth rate, g, is 3% per year, 0.03. But recall that our growing perpetuity formula assumes that the first cash flow occurs 1 year from now. But these cash flows start in year 8. And so if we use this formula, we're actually getting their present value as if we were sitting in year 7. And so we have to discount all these cash flows an additional 7 years. And so we have to multiply by 1 over 1.15 to the 7 to discount them an additional 7 years. And when we do that, we calculate that the present value of all our cash flows in year 8 onwards is going to be equal to $63.6 million. So this is equal to $63.6 million. And so to get the present value of all our cash flows, we take the present value of our cash flows from years 1 through 7, and we add this horizon value, this value of what we assume these cash flows are going to grow in perpetuity. And so when we do that, the present value of all our cash flows is equal to $113.5 million. Now, the present value of all our cash flows is the total value of the assets of this company. It's the market value of the assets of the company. And so in order to get the value of our equity, we have to remember to subtract the value of the debt. And so the value of our equity, the value that can be claimed by shareholders, is going to be equal to $113.5 million minus the debt, which is $40 million. And when we do that, we get that the value of the equity is $73.5 million. And now we only have one more step. And to get the value per share, we have to take the total value of the equity and divide it by the number of shares outstanding. So we have a value of our equity of $73.5 million. We divide by our total number of shares, which is 2.5 million shares. And when we do that, we get an estimate for our value per share of $29.40. And so this is a very precise estimate, but you have to be careful because a lot of assumptions went into this model. And so if you're going to use a discounted cash flow model like this, you really have to be careful and you have to think very critically about all the underlying assumptions that went into making these projections.